Welcome Shubham, welcome Smaran. Uh, so today we are going to be discussing about customer churn webinar, where we'll be trying to understand that how do we predict churn in advance, how do we reduce the churn, and once we are using machine learning to predict churn, then what next? What else can we do using machine learning, and how can we get to that step? As well as we'll be discussing that how do you strategize after that point, because getting predictions is one thing, but you also want to be strategizing after it. What next? Okay, because a lot of companies we deal with at Cliently, we give them the predictions, and then they come up with okay, what do we do with predictions now? We know that this person is going to be churning in 2 years from now with a probability of 0.8, but what next? What do we do? So that is the most essential part that you'll be taking away from this webinar, where we'll be discussing that what are the next steps after you get the probabilities, after you get the duration of time in which a customer is going to be churning. So basically, yes, and we're going to be using it's mostly an executive kind of a case study. So I'll not be doing coding in Python or R or anywhere. We use our no-code AI environment, so we'll be using that one for this. So welcome, guys. Those who are joining us. Also, guys, let me know where you're from. I'm always curious to know. We have like a very diverse audience. So happy to know. I'm from Oklahoma City. It's a very small town in Oklahoma, and Oklahoma is in north of Texas. So yes, I lived quite my life in New Delhi, India. Now in Oklahoma City, huge difference. A lot of people, not many people. So I miss being around with a lot of people. Michigan, that's wonderful. I once went to Michigan. Loved the nature. We've got 2 more minutes to start, so we'll be exactly starting at 1 p.m. my time. Algeria must be quite late at night. Huria. California. London, must be 7 or 8 p.m. India must be 12 right now. No, not 12, 11:30. That's pretty late. I usually... Perfect, guys. Keep coming in. Welcome those of us who are joining. Abhiraj, welcome. Aduna, welcome. Alan, welcome. I think Ashwini, welcome. Sorry if I get your pronunciations wrong. I need to wear my glasses. Welcome Neha, welcome Christian, Saurabh, Vaishnavi, Thomas. Do let us know where you guys from. So as I said, we're just going to start in 1 minute from now. And again, today, guys, so first half an hour, we want to be focusing on the case study. We want to be focusing on, first of all, what is customer churn? Why do we need to do it? Why do we need to do it using machine learning? And then we'll be taking up a case study, a hands-on workshop. And then we'll be going about like, what are the next steps after we get the predictions? What do we do next? So that will be important. My name is Harsh. Everybody knows I work for Cliently. I'm the head of AI at Cliently. And we deal with a lot of marketing sales teams. We try to get them up and going with a lot of machine learning predictions in a very consumable way, so that they can take actions right from their dashboards. So guys, I'm going to be sharing my screen now. It's 1 p.m. Like to start on time. Do let me know if you cannot see my screen, or if there's any problem in the audio, video. Let it keep coming. Where you from? Would love to see it. Ireland. That's again 8 p.m. I guess. Okay, perfect. Guys, any problem in seeing my screen? Everybody can see the screen? Yes, no? Can any one of you? All good? Okay, perfect. Guys, welcome to this webinar. This webinar is all about churn prediction using no-code AI. So I'm not going to be diving into the technical code aspect. I'm just going to be looking at what are the possibilities and how you can be doing it. So essentially, it's for people who are not good with data science as well as people who are good with data science. My name is Harsh Gupta. I'm the head of AI at Cliently. So we're going to be talking about customer churn, what it is. Then we're going to be doing some hands-on workshop, 5 to 10 minutes, where you get an idea that how we come about with the probabilities. And then we want to be understanding the factors that are leading to churn, that how can we reduce churn, because that's the most important question if you're working in a marketing and sales. And then the action plan. Okay, so we got to the factors that are leading to churn, but what next? What do we do? So a little bit about me. I've worked in a lot of industries, mainly e-commerce, healthcare, non-profit, consulting. And I have a good background in marketing, economics, computer science, data science. I've been working for the last 8 years as a data scientist. This is my email. This is my LinkedIn. Do add me on LinkedIn if you want to, Harsh Gupta. Okay, so we're getting down to the starting time, okay? So those of us who are joining late, this is the right point where we're just getting started. So what is customer churn? Customer churn is when people unsubscribe from your product or services. Now let's just look at this this picture. So there are 1,000 people who started with you, let's say 1 year from now. And today, 1 year after that point, there is a 5% churn. That means 50 people left your company. And this is a huge problem, especially when you're offering something recurring. For example, if you're a newspaper, for example, if you're a software as a service business, you offer monthly plans, annual plans. So huge problem, especially with software as a service business. You offer something on monthly installments, on monthly plans, annual plans, etc. Now, why is it a problem? Try to understand. Acquiring new customer is so costly. It's just going to cost me 4 to 8 times more. That's really bad for my business, right? Bad word of mouth. If somebody is churning, they're also creating a bad word of mouth for your company. Let's just say if today I'm switching from one product to another, so I've churned for that product, I'm not going to be talking good things about it then, right? There was a reason. That's why I churned. So then I'm losing more customers. As a business, I'm losing more customers, which I could have gotten from those churned customers. And another thing, like there are so many new websites like G2, Gartner, customerreviews.com. There are just so many trustedreviews.com. So if there is a high churn in your business, you're also going to be reflected in the negative reviews on those websites. And that's again bad, right? If I'm going to buy your product, I'm going to be looking at your reviews. And then there are so many churners who are writing bad reviews about your business. So again, bad thing. The new customers, you're also creating a blockade for the new customers to come in. Businesses thrive on relationships, and relationships needs to be nurtured. They take time. It's like growing a plant, growing a relationship. It takes time. It needs to be longer. If your customers are cutting off in a few time interval, that's a problem. The relationship isn't being built. Now, I see a lot of businesses talking about reducing churn, let's do this, let's do that. But Very few businesses are doing predictive analytics today. So what are they doing now then? Okay, I see many gurus on Facebook and LinkedIn selling books and charging $10,000, $20,000 for consultation, and they'll come up with, okay, we'll come up with top 10 ways to reduce churn. We'll find you 50 ways you can reduce churn. You can find so many books on Amazon everywhere. And look, up to a certain point, like up to a certain thing, it's fine. Like they'll say improve the customer onboarding. Okay, I'll improve the customer onboarding. It's a very generic statement. Improve the customer experience. Okay, I'm working on customer experience, but it never gets down to what exactly is the psyche of the customer and why is the customer leaving us. And everybody has a different reason. So these generic reasons like the top 10 ways to reduce churn just aren't enough. And then I'm seeing a latest new trend. I get a lot of LinkedIn connection requests, and I see this a lot. Churn crashers. I've recently seen this word, and they have absolutely no knowledge of predictive analytics. Nothing against them, but just that you're going to crush my churn. Churn crushers, it should have been. You're going to crush my churn, and you don't know predictive analytics. Then how are you going to do it? It doesn't make sense to me. A lot of companies also rely on the intuition and the domain knowledge. Okay, if the customer calls us more than 4 times in a month, they're going to be churning. These are the negative signs. So let's just do something about them. Let's just give them 50% off on the monthly plan. That's such a bad planning. First of all, not every customer is going to be incentivized by the discount. Secondly, a lot of customers had different problems. They were about to be churning and you just gave them 50% off. So you're in the loss-making business now. Really bad strategy. Worst case, accepting churn as a part of business. No, it doesn't have to be. If there is a churn, if you're a decent sized business, I'm not talking about like you have 10 employees, 5 employees, but if you're a 20 plus employee company, you have a decent business that you've proven over the time, and you're having churn, you cannot accept it. That's not part of the business. No, you can cut it down by huge margins. Why machine learning? So first of all, we need to be proactive and not reactive. If the customer is churning today, then it shouldn't be like I'm calling the customer tomorrow. Hey, Mr. John, why did you churn? Can we do something? Can we give you discount? No, that's very reactive. Once the customer has churned, can't do anything. Like bringing them back to the door is so challenging. Every person churns for a different reason. We need to predict in advance. Simple. Different psyche, different reasons. Somebody's price conscious. Somebody doesn't like your service. Somebody wants to make a phone call to you. You never get a person behind the phone call. Just so many different reasons. And you can't have one size fits solution for all. You can't say, okay, let's improve the onboarding of customers and suddenly the churn will go down. No. To some extent, yes, but you can't have one size fits solution for all. And that's when the beauty of machine learning comes in. And I want to give you an overview of machine learning process here. So first of all, you decide a cutoff date. You have historical data set. So let's say your business has been in existence for 5 years, and then you're looking at churn you're looking at annual churn. So you give people 1 year of time and see if they continued your product or services. And if they've continued, that means they've not churned. If they've discontinued, that means they've churned. So you need to decide a cutoff date. Maybe your business subscription is 5 years on average, or the majority of the people are buying 5-year plan. Then you need to have a churn for the 5 years and not 1 year. Maybe you have a monthly churn happening a lot. So then you need to do a monthly thing. And then you need to combine all the data points from HubSpot, from Salesforce, from Pipedrive, wherever your data sits. You need to combine it. You need to make it one row per customer data set. So once you have that, you need to clean data. Look, you need to treat outliers. You need to do the normalization of data. You need to looking at the abnormal values. You need to be understanding your data. There's just so many aspects of cleaning the data. Then you need to do a lot of feature engineering. So machine learning models just understand the numeric information. They do not understand English. They do not understand text. They do not understand the date columns even. So if there's a date column 04/04/2020, you need to make it in such a way that the machine learning can consume it. So you need to extract the month, the day, the year, the distance, the time between the holidays and this date. If there's an address, you need to extract the zip code, city, state name, etc. And then you need to do encodings on it, because otherwise the machine learning models don't understand. And then you start building models and you tune parameters. So there are so many models. Usually tree-based models are the winner models. And then you need to tune the parameters so that you get to the best model with the best properties. Every model has different properties. So think of it, a decision tree, I may split it 3 ways, 2 ways, different properties. So I need to find out what the best parameters are. Usually Bayesian optimization is a pretty good method. And then comes the understanding part. Okay, so you need to give the probabilities that this is a probability of churning and in how much duration the people are going to be churning. And then what are the action plans? How can you immediately bring down their churn probability? In long term, you can understand the drivers behind the churn and actively work on it. Maybe 45% of my people are churning because of the bad customer onboarding experience. So over the time, you need to work on the customer onboarding, because majority of the people are churning because of that alone reason. But again, that advice should not come from a churn crusher. That advice should come from machine learning, statistics. Okay, so let me dive onto this data set, telecom customer churn data set, very popular data set. It's on Kaggle. And okay, so this is the data set, a very popular data set. It's on Kaggle. And I'm looking at these people, the churn or no churn. Okay, so churn, no, the people haven't churned. Churn, yes, people have churned. And there are many values associated. What is the sex of the person, partner, what is the monthly balance, what is the contract, just so many things. Okay, so now essentially what I'll have to do is, I'm not going to be doing it, but if I were to do it by myself, I would just open up Python. I would write lines and lines of code to clean everything, feature engineering as I discussed. But since it's a webinar, I'm going to be using our no-code environment, which we use. So what I'm going to be doing is, I'm going to be uploading the data set. There's a telco churn data set right here. And then I'm just going to be defining the target, that what do I need to be predicting. So this is kind of automation of machine learning. Instead of writing lines of code, I'm just going to be defining the target variable and the ID of the person, and then I'll just start the analysis. So in the back end, it's going to be doing data cleaning, feature engineering, machine learning. So I have a report created, no worries. Yes. So I'm looking at this. I ran a couple of models. I got XGBoost as my winner model, and it has a accuracy of 80%. That means, and this is on the test data set, that means 80% of the times I'm getting the right predictions. 20% of the times my predictions are off. I'm predicting wrong. So I'm looking at the confusion matrix. Again, it's telling me the same picture. The real value, yes. The predicted value, no. So for example, I'm more concerned about the real values, yes. Predicted values, yes. So 180 times there was actually churn happening and we got it right. So this is a confusion matrix kind of. I want to be. So we'll just do the scoring part, and we want to be getting the prediction. So we've done the machine learning model building, and now we come to the scoring part where we want to be seeing. So this is the data set for the scoring. Now, for those of us who may not understand what scoring is, so I built machine learning model for this data set, and I calculated that this is how the data cleaning needs to be done for this data set. This is the best model. So I saved it somewhere. And now I'm going to apply it to this new set of people whose churn we do not know. Look, there was a variable called churn. In this data set, I do not have that variable called churn. I do not know if these people are going to be churning or not. And that is the beauty of it. I want to be predicting if they're going to be churning or not. So again, this call be called scoring. This call be called deployment. It has many names. I call it scoring. Okay, so I'll get the values after I'm done with the scoring. Okay, by the way, I was showing you so this is the data set now, the score data set. So after I'm done the scoring, I got the predicted values. I have the class no probabilities and class yes probabilities. And remember, there is no churn variable. So there's no way I can say that if these people are going to be churning or not, but only using machine learning modeling on a historical data set. Now on the new people, I can predict if they're going to be churning or not. So it says me that this person is not going to be churning, this person is going to be churning. So now I want to be looking at the people who are going to be churning. Okay, so I have this person, there's a probability of 0.676 of this person's churning, and these are the set of values. So now I have the probability of everybody churning. Now I can actually sort it out, sort descending. Okay, so these people have the highest chances of churning. This person, 0.706, 0.705. And as I go towards the very end, the probability comes down to 0.5. So we have a cutoff at 0.5. Anybody above 0.5, we say that this person is going to be churning. Anybody below 0.5, we are saying that this person is not churning. Okay, good. So now we have the probabilities. Now you'll ask me, like other companies ask me, okay, Harsh, we have the probabilities. What next? What do we do now? So now we need to be understanding that what are the drivers behind the churn? How are we going to reduce the churn? And the people who are going to be churning, what do we do with them? Can we stop that churn? You got the probabilities, fine, good. Now comes the next part. So first of all, I want to be looking at the summary. So there were how many variables? If I get here, there are 21 variables. Okay. So out of the 21 variables, contract is the single most important variable in deciding churn or no churn. Then the second most important variable is tenure. Internet type is the third most important variable. Then comes the online security. So this is the importance of the variables that are affecting churn, that are causing somebody to churn. Or in other way, we can also say that these variables help us differentiate between the churn and the non-churners. They can easily segregate the churn and the non-churners. Okay, so contract is important. What next do I do? So let's look at the variable contract for a second. So there are three levels to this variable. Month to month, there are three types of contract: month to month, 1 year, and 2 year. So when the contract is month to month, there is more churn. The churn goes up. When the contract is 1 year, there is lesser churn, and when the contract is 2 year, there is even lesser churn. So what that means is, whenever people are in month-to-month in a month-to-month contract, there is always going to be more churn. So a broad strategy would be a broad strategy, not an individual strategy for every individual. A broad strategy could be that me as a telco company start pushing plans to be on 1 year or 2 year plan. Maybe I give them 10% discount on a 1 year plan. So that's kind of one strategy to bring them 1 year to 2 year. 2 year would be the better thing. So remember, we saw that contract is the most important variable. Now let's look at the tenure variable. So tenure is essentially the number of months the person has been with the company, with that contract. So I look at this, the lower the tenure, the more the churn. Okay, so look at this one. From 0, this starts at 0. And this is so high. And from this point, there is a dip. So 0 to 5 months, there is huge churn. On my 0 to 1 is churn, 0 to -1 is no churn. So churn, 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 churn. And then at this point, at 17 and a half months, there is suddenly more number of people who are not churning. So that is good. So that tells me essentially that between 0 to 1.5 months, I'm going to see a lot of churn. So again, a broad strategy could be that I have to be super careful with my customers between 0 to 1.5 months, super careful. Otherwise, they'll churn. From 1.5 months to 5.5 months, I need to be more vigilant. Not as much, but still need to be vigilant because there will be a churn. But at this point, when it starts going no churn, after 17 and a half months, I can take some breathe. Like I can assign less resources to people after 17 and a half months. And then look at this. After this, the churn is going down, 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 down. And it is the lowest after how many months? After 70 months. So after 70 months, the churn is the lowest. So that's how the broad strategy I'm talking about. Internet type was another important variable. Now, I'm not going to go into every variable, but you get a sense of how to make a broad strategy. Now, I want to be looking at some other things. Again, broad strategy. In a couple of minutes, I'll be talking about how we can do an individual strategy as well. So I'm just looking at this person, for example. We predicted that this person is going to be churned with a probability of 0.675, and he actually churned. So we got it right. Now for this guy, I'm looking at tenure is 2 months. And remember, lower the tenure, the more the churn. So this, the tenure has a high magnitude. This variable alone, tenure, which value is 2 months, is causing this person to churn. Contract, month to month, again, a bad indicator. This is causing the person to churn. Internet type, fiber optic, causing the person to churn. But if you look at the blue one, these variables are causing the person not to churn. So for example, this variable, the multiple lines is equal to no. This is causing the person not to churn. The stream movies, the person doesn't stream movies, causing the person not to churn. But these variables are so big in magnitude that they're influencing this person so much that this person actually churns. So this is kind of way to understand that what variables and what values are causing people to churn. Again, it's just extending this explanation to this one. So this is done. The broad strategy is done. Now I need to be doing an individual strategy. And we call this causal modeling, that we want to be understanding that what and why behind the predictions. Okay, this is something interesting. I want to be doing a monthly balance because I'll be coming on an individual predictions now. Okay. So look at the variable monthly balance. First of all, let's look at the variable monthly balance, how important it is. Monthly balance is 7th or 8th most important variable in the rankings. So now let's look at the monthly balance variable. So all the way it looks like pretty flat line, but if I were to just, let's say zoom it, okay? Let's say we are zooming it. And I'm looking at the monthly balance. Whenever, see, suddenly there is a spike here. Suddenly the churn goes up between 105.875 months till 106 months. Okay. So essentially, let's just take this line and then the churn is back to the normal level. So between 105 to between $107, I'm suddenly seeing a higher amount of churn. And let me write down that number because I'll be using that number. Is this the one? Okay, this is the one. Perfect. Between 105 to 108 dollars of monthly balance, there is higher churn. Okay, perfect. So now, as I was saying, now we need to do an individual predictions. The broad strategies are fine, but now how about some individual predictions? Okay, so let's say auto filter. I'm looking at these people, yes. And I need to be looking at, look, I cannot change sex of the person. I cannot change if the person is senior or not. So the variables which are in my control, I will try to change them. The variables which are not in my control, I cannot change them. So I can definitely do something about the monthly balance. So let's look at this variable. Let's sort it. Sort descending. Sort. Okay. I'm going back to this one between $105 to $108. Okay, perfect. Between 105, this from this person to. Okay, perfect. As I was saying, that every individual is different. These people, just give me 1 minute, insert above. I'm so bad at doing Excel. That's why I can not do good things at Excel. Okay, so monthly balance. So these set of people, I know that they're going to be churning and they have a very high probability of churning. And I know these guys are churning because of the monthly balance. Why? Because remember when the balance is between 105 to between $108, suddenly we are seeing a spike in churn. So I'm going to be giving them these bunch of 12 people. These 12 people, I'll try to bring down their monthly balance. Bring down monthly balance. Maybe I'll give them 10% discount. Give them 10% discount if they clear their monthly balance in next 5 days. So that way, if their monthly balance goes down, there's a very good chance that their churn will also go down. Again, just a very small explanation on how you can do on a very individual level as well. Let me get back to the presentation. As we saw that we scored new customers as well. So we've got three or 4 minutes left. Now so we saw a lot of automation, right? We didn't have to do any machine learning. We saw a lot of automation, but still we had to insert the data somewhere. We had to look at the Excel file. We still had to do a lot of manual things. So that is where I think our tool is really great, because we work with a lot of marketing and sales teams and we provide them views like this. Okay, your customer has a churn probability of 75%. You send them an email at 2 p.m. and there is an 88% likelihood of improving the churn. So all that manual calculation you saw, we have it all automated and we provide it to marketing and sales teams on a very automated basis. Again, not trying to pitch the product, but I'm just showing you the power of automation that can be accomplished just for a very simple problem like churn, and no more buying books, top 10 ways to reduce churn. Actually, and if you're a data scientist, you could perhaps try it to in your organization. Show your marketing sales teams the churn reduction score and what exactly are the steps that the marketing and the sales reps should follow to reduce the churn. So with that, guys, I'd like to say thank you. Wonderful to have you all. Let me share something with you. Let me share the deck with you. But I'm open to questions, comments. Please put it out in the chat. Anything you didn't understand, I'm happy to explain in this next half an hour. And I love this, Mihim. Actually, one of our somebody who joined us recently, they just made it, and I love it. You're not using client views, no-code AI to predict customer churn. Good luck if you don't have a team of data scientists, because it's going to require a lot of work. Or you can use our platform. So guys, open to question. Let me share. By the way, if anybody wants to discuss anything with me after this, I'm happy to have a conversation where I'm going to be. So this is our Calendly link. If you want to have discussions around customer churn, if you feel you're a business struggling with customer churn and you're tired of paying the gurus tens and $15,000 and them giving out generic advice to you, I'm happy to have discussions with you. This is our Calendly link where we can have conversation with you, give you really automatic AI predictions and action plans to your sales reps, marketing reps, so that you can reduce churn. Guys, with that, open to questions, comments. Okay, sharing the slide. Yes, Huria, sharing the slide. Give me 1 minute. I'm sharing the slide with everyone. Copy link, done. This is the link of the presentation. Okay, so there are some questions. Let me start with the questions one on one. Guys, by the way, we have such a diverse audience. I'm just checking out. We are all around the world. That's actually good. The webinars bringing us closer. How do you derive the so there's a question by Uday. How do you derive the test data set? So what we do is, and this is actually a good data science practice. So you have the data set, you divide it into 10 k folds or as many k folds as you like, and then you run the training on some k folds. You check out the predictions on some k folds. Use stratified sampling, or in a very simple way, you can also divide your data into train and test split or train and test data set. Some people also like to add a layer of validation data set. So usually most of the time people keep 60% training, 20% validation, 20% test data set. And then you do the model building on the training data set, and then you check the performance on the test data set. So remember, I was showing you 80% performance that was on the test data set, not on the training. On training, of course, you get a good performance. So you want to be hiding that test data set from your model building and later checking how well this thing is doing. Okay, I think I answered your question. So Ilya has a question. What is the most valuable task to improve the accuracy of churn prediction? As I said, models, you don't need to build many models. You don't need to build like 35, 40, 100 models. You don't need to tune the parameters all day. You can use Bayesian optimization. The most daunting task is, and the time that takes most amount of time is your data cleaning. You have to understand what type of data you have. You need to look at if the NA, the not applicable are the same. Just a small example. You need to be looking at outliers, missing values. You need to be standardizing your data, normalizing your values. There are just so many components to it. So that takes a lot of time understanding your data, and then perhaps cleaning the data once you understand it. The second part is the feature engineering. So for example, if you have a customer chat column, you cannot use as it is in machine learning. The machine learning just understands the numeric information. So if you use the chat columns, it will just discard it. I don't understand what you're showing me. So you need to convert in this case, the chat column into numeric information. Like you need to calculate the sentiment, you need to calculate the subjectivity, you need to calculate the text clusters, the text topics, use a lot of NLP libraries. I give an example of date column. Let's say if it's an address column like 1400 20th Street, Northwest, Washington, DC, 20036. I shouldn't have given my personal address, but so if you have the address, machine learning won't understand. You need to break it down: zip code, state, city, the building number, the neighborhood, and only then the machine learning will understand. Oh, by the way, even then it won't understand the English, whatever the language is. You'll have to convert it into numeric. So you'll have to do one hot encoding, maybe mean encoding, target encoding, this cat boost encoding. There are some 8-9 types of encodings that you can be doing. So that thing will take a lot of time. Okay, so what are the other questions? Can you please share the slides? I did, Uria. Okay, Chile. I think they're in the same time zone, Alan. Chile, same time zone. So this is a question. What attribute features you would recommend in a more dynamic setting? Like an online game where people is almost a daily basis interacting with the app service tendencies. Give me 1 second to drink water. Okay. So that's a very good question. So the question is that what do you do when your variables are changing all the time, when it's a very dynamic setting, like an online game where people are almost on a daily basis interacting with an app service. So also the question is that the behavior of the people is changing on a daily basis. The habits of people are changing on a daily basis. So in that case, and we have it right now built, and we highly recommend that in such a scenario, the predictions need to be real time. So first of all, by dynamic setting, if you mean by the variables are changing all the time. So for example, this person was playing an online game. He logged in right now. He played for 1 hour and then he went out. Another player logged in. She clicked on 20 buttons in the game and then she bought 20 coins. So the variables are very fast changing. The values are changing as well as new people are coming in, the old people are going out. It's just very dynamic setting. So in that case, we highly recommend that first of all, you need to have a very good number of observations, a very good number of historical data set, so that all these dynamic things, all these values which are changing so fast on a daily basis, we're able to take that account. So machine learning is nothing but it identifies a cluster of people who act in a similar way, right? And if you have a lot of users coming in every day, so machine learning needs to have more data. So we have more data, fine, we do model building, and then we're doing the real-time prediction. So let's say Mary comes in, Mary plays for 1 hour, and we give a prediction that she's going to be buying $100 from this app, right? And then Mary logs in immediately, and then she buys another $20 from the app, right? So then that $100 gets pushed maybe to $150, $160. So we need to run predictions like in real time because these values are changing all the time. And this is where a lot of companies are investing in ML ops. Machine learning is fine, but we need it in production. So they invest in ML ops. For us also, this real-time predictions is a huge thing. A lot of people just change values. Sometimes people click on that email and the value of the churn immediately changes. So we do a lot of real-time AI predictions. Also, the second part of the question is tendencies are good there, is interacting. Yes, Thomas. So I addressed that part as well. The values changing of the variable. We are building models all the time. And remember the scoring component as well. So we built the model, and then for the people whose churn we did not know, they were new to the data set. We had no idea if they're going to be churning or not. We did a scoring on them. So at the very minimum, if you are an organization and if you cannot achieve real-time predictions every second, every 10 seconds, every minute, every 5 minutes, you can do a lot of scoring. And so what you can do is, if the users are coming in every day, the values are changing every day. So perhaps at the night time, you can run the model building because the model building will take time. So you can run the model building, and then you can have a setting where you're doing the scoring of people. Anytime the value of any variable changes. So for example, Mary, she clicked on one more button in last 1 hour. So you can have a setting like every 1 hour, the values have changed. Whichever people have the values changed, do a scoring, pass them through this model that we've already built. So at the night time or every week, you can run the models. They'll learn from the data. And every 1 hour, every 1 minute, whatever the frequency you want it to be, you can do scoring for the other people whose values change. If the John's values are not changing, then we don't touch him. His probability of churn is the same. But if Maria clicks on links, her churn probability goes up or down, and we use her. We just throw her value in the scoring. We automatically connect it, and we give her a value. Again, you'll have to invest a lot in the ML ops. We call this ML ops. This is big infrastructure. You'll have to invest on it. We also work with the teams in the ML ops. As I was showing you that we give them real-time predictions. So kind of real-time predictions, scoring, all happening within our app.cliently.com, and in a very easy consumable way. So if you like, you can set up our own ML ops infrastructure. You need some data scientists, engineers, or perhaps use platform like ours, which makes it easier. Okay, how are you taking care of overfitting the model here? Good question. Again, going back to the same part, train, test. So we are running it on the train. We're ensuring that there is no overfitting by, let me give you an example of decision tree, okay? Let's say a very simple decision tree. We are splitting and we're splitting on 2 branches only, okay? So at one time, I'll stop the decision tree. I'll say that, okay, if one of the nodes get lesser than 1% of the observations, stop it. So that is one very simple way of avoiding overfitting, that when it starts getting very small, we say stop it. Don't prune it anymore. If it's a tree-based like model, if it's a neural network, if it's linear regression, again, similar kind of logic, but not in a tree way. So that is one thing how we are avoiding overfitting. The other way we are avoiding overfitting is we are asking model, okay, look model, in case 1, you can overfit as much as you like. In case 2, don't do much overfit, just do an okayish. In case 3, don't do any overfit, like do up to a good point, but don't do beyond that. And then I'm going to test them on the test data set. I'm going to see the performance. I'm going to see the weighted F1 or the accuracy. So let's say for this one, the case 1, where there was so much overfitting, it won't perform well on the test data set, right? I'll get an accuracy of maybe 70% because it never saw that data set and it overfitted. So it's doing bad predictions. For case 2, maybe I get 75% accuracy because it overfit, but to a decent extent. Case 3, maybe I'll have an 80%. So we let model decides. We are also doing some controls, but we also let models decide by the test data set. Now remember, we were doing hyperparameter tuning in every model and we're trying out various models. So if some model is overfitting and if some tuning, if some parameters of those models are fitting like real bad, they perform bad on test data set, right? So they're not shown to us. Only the parameters and only the models with not so much overfitting, which perform really good, only they are shown in the model dashboard. And you should also do the same thing. Do those controls as well as use the parameters, and the parameters which are not performing good on test data set, you don't consider them. Guys, I have to say, a lot of good questions. Okay, Smaran has a question. How do we prioritize among the evaluation metrics for a churn model, say among recall, precision, and accuracy? Okay, so the question is that how do we decide what is a good metric for choosing a model? Is it weighted F1? Is it accuracy? Is it recall? Is it precision? Depends. If you don't know anything, you would choose weighted F1. So what weighted F1 is doing is it is balancing out the classes. So it is saying, okay, you're getting the lower class. Remember the churn yes was equal to 15%, churn no was 85%. So what weighted F1 is doing is it's saying, okay, I'm going to give 50-50 weightage. If you get the churn yes predictions wrong, I'm going to penalize you. If you get the churn no predictions wrong, I'm going to penalize you equally. So if you have no idea, you use weighted F1, you use MCC, you use KS statistics, those 3 metrics. You can use and some other metrics as well. And never use accuracy because 15% churn, 85% no churn. So even if you're predicting 15% churn wrong, you'll still get 85% accuracy. And that's bad, right? You're predicting all the people who will not churn right, but people who are churning right, you're not predicting them wrong. So that's not helping the business. So you don't know anything, use weighted F1, MCC, KS statistics. But if you know that what is important, so maybe in this case, what was important to me was the churn. That's a yes, if the people are going to be churning or not. So then I'll use precision or recall accordingly. If I know what I'm doing, then I'll choose one of these, precision or recall. If I don't know, then I'll do a weighted F1. And if the classes are balanced, then I do accuracy. Is it possible to share the code? Huda, you just destroyed our business model. So we have like 50,000, 60,000 lines of code, and that's our proprietary code, our intellectual property. We cannot share it with anyone, and that is why our business is making money, right? If you share the code, if you put it on the open source, for us that will be 100% churn. So you won't have to even do predictions, like 100% churn. So can't share the code. But if you go to the kaggle.com and if you look at the telco data set, you'll get some basic code that you can use it. And that may help you, not to a good extent, but will help you to some extent. What about B2? So Abhilash has a question. What about B2B companies in which the churn class is substantially low compared to the no churn class? How far back in timeline we must include our data for? Thanks. Good question. And as I said, really depends on the business. So think about it. Today, I was reading the Wall Street Journal, and I also read Bloomberg Business, right? I unsubscribed from Bloomberg. I don't because the content is mostly similar. Also, Bloomberg is on the television. So I decided not to continue the Bloomberg Business. So I'm a monthly churner now. Why? Because I was paying month to month, and then I churned on a monthly basis. So for a company like Bloomberg, newspaper I'm talking about, most of the subscriptions are monthly. So then they would be looking at a monthly churn rate, and maybe they would take 24 months of data. How do you come to know about what exactly, how much the duration, the time you should be going back? That depends on your nature of business. So if your average number of customers are churning in 5 years, so then I would be looking at a 5-year data. If most of my customers are churning in 2 years, then I may want to be looking at last 2 years of data. So that is the essence. You need to be looking at the median, the mode. You need to be looking at the nature of your business. No one answer. Most of the businesses I have worked with, and we are working with Cliently right now, we do a 1-year thing. Why? Because it's generic, it's standard, and a lot of plans, especially in a software as a service business, you see. So they'll offer a plan monthly, $100 a month. Yearly, they'll say $100,000 a year. So that is, you save some $200. So a lot of people like to go with yearly plans. So monthly, yearly plans are very popular. So a lot of times we see 1 year or 2 year happening. But again, really depends business to business as well. Do you provide time to churn? So Uday has a very good question. Do you provide time to churn? The time it takes to exceed the threshold probability? Absolutely. So how you need to be doing is, first of all, let's get into that one. So there's something called survival analysis. And using survival analysis, you can easily predict that when your customers are going to be churning exactly. Are they going to be churning 2 years from now, 5 years from now? And then you can take an action. So we have it inbuilt for the marketing and the sales teams. You want to do it yourself, you'll have to do survival analysis. There are a lot of methods, coupler. There is a lifetime model as well. There are some models in sklearn as well. We have it automated for the marketing sales team. Survival analysis is the way to go. Okay, guys, I'm speaking so much. Give me 1 minute. Let me drink some water. Okay, so Google has a question. How can I develop my knowledge of the business processes? Customer churn can be done in various domains, and in order to convey my results in terms of business, I would like to expand my knowledge on business. Could you please tell me? Okay. So the question is that I am a data scientist, okay, and when I present my finding, and I get this question a lot. I'm a data scientist. When I present my findings to the teams, they do not understand it, the marketing and the sales teams, and they do not know what to do with it. And that part, really, the blame is on us. As a data scientist, the blame is on us, not on the marketing and the sales team. And how do you go about it? First of all, what's wrong? Sometimes we are too technical. we don't know how to explain our findings to the audience. And I have learned it over the years that businesses care more about what to do next than just the predictions. And probably that's why many of the gurus and the advisors and the business coaches are making so much money, because they're just telling you, okay, do these four things, do these six things to avoid the churn. They're not giving you the probabilities, right? But they're telling you what to do. So that is why they rake in so much money. So if you're a data scientist, you need to understand, you need to talk to the stakeholders, find out what exactly they're looking for. And once, most of the time you'll understand is they're looking for the action plans. So remember the whole feature importance thing, the whole tenure thing, the broad generic advice, the suggestions that you should be doing from month to month to 1 year, 2 year. All that is part of something called explainable AI. That you need to be understanding that, okay, why the churn is happening and how can I reduce it, as well as you need to be predicting on an individual level. So remember that thing I showed you in the Excel, that look, when 100 to 500 to $8, there's a monthly balance. Suddenly the churn goes up just for that bracket. And then I looked at the 12 people who were about to be churning and their monthly balance was falling between $105 to $108. And then I suggested, let's just give them 10% discount on monthly balance, because these 12 people are only going to be churning because of the monthly balance. So that's a very business oriented mindset that as a data scientist, you need to be having. Probabilities are good, but they're just not everything. And again, I can tell you that at Cliently, why we are so successful. At Cliently, we are so successful because we give marketing and sales teams predictions in a very consumable way. So that if the marketing reps open up, they see, okay, for this person, this is the probability of churn. If I do step one, the probability of churn goes down by this. If I do step two, the probability of churn increases, decreases, and in how many months, year they are going to be decreasing. And that is why we are so successful in our business, because we don't know anybody who's providing predictions like that to marketing and sales teams. And if you think of it, like, it's actually kind of writing code, right? Giving predictions in the Excel file and uploading it on a CRM. I mean, if you think of it, it's like that simple. But the easier you make the information to be consumed by others who are non-data scientists, the more success you'll have in this domain. The more you understand their requirements, the more you understand what they're looking for, the more you'll be successful. And I like to say, do a reverse psychology. Just think about why and how the business consultants are making so much money when they give you very broad generic advice. Right now, if you just search that, how do I reduce churn book, you'll find like $100 books on Amazon, which will give you tons and tons of generic insights, and they make so much money. Why? Just do a reverse psychology if you're a data scientist. And I'm sure as a data scientist, high IQ, you can get to that. I'll take the next question. So Huda has a question. How did you get the probability of each customer if he is going to churn? How do you get the probability of each customer if he or she is going to churn? Okay. So essentially, so we clean the data, we do the feature engineering, and then we are asking the models to find the properties which are making somebody churn and the properties which are not making somebody churn. So machine learning is essentially finding rules. Okay, if tenure is more than this, if sex of the person is this, if the person has no gender, then the churn probability is more than 0.95. That is essentially what machine learning is doing. But I'm oversimplifying things. Not that simple. But if you don't understand, like, think of it as doing an if-else condition. If this, then probability is this. If this, then the probability is this. And then it gives a probability to every person. And then we set off a threshold or a cutoff. And that's really up to us. We can set any cutoff. If a cutoff is more than 0.5, we say the person is churning. If the probability is less than 0.5, we say the person is not churning. So that's what is happening in the backend. But I oversimplified about the if-else. It's usually not that simplified. Okay, guys. I think if you have question coming in, please let it come in. We've got 5 minutes more. By the way, this is our Calendly link. If you want to book something, if you think your marketing sales teams are struggling to find out the customer churn and they want automatic AI predictions at sync, real-time sync, we're happy to have those conversations. Okay, so guys, with that, like if there's no more question, I'd say I'd like to wrap up. Another thing before I go out, we have such webinars every week where we're talking about some new topics. The next topic is that how do you do lead scoring using AI? So businesses have lots of leads coming in. How can you score the leads using no-code AI? Again, it's going to be something which is going to be very non-data scientist. Anybody can consume it. Of course, data scientists also will understand the business aspect of it. So you can follow our page cliently on LinkedIn. We have events. You'll be notified of the events. Again, cliently.com, LinkedIn page. We have our events on LinkedIn. We just post it out there. So thank you, Gokul, for attending, and thank you everybody for coming for this webinar. Wonderful to have you all. Looking forward to see you next week, Thursday, 1 p.m., same time. You can check out the page cliently and it will be there. Thank you, guys.